Now, in this section here, 8.3 deals with a correlation coefficient and coefficient of linear determination. Okay. Simply stated that correlation deals with things that are increasing together or decreasing together that appear together. Coefficient of determination has to do with how much the input affects the output. How much of the input affects the output. Okay. So, with those things in mind, um, they ask us to do A and B here. You correlate data on average number of emergency room visits per month and a percentage of ER patient deaths per month at hospitals around the country. The coefficient of determination is 0.92. Use this statistic in a meaningful sentence. Compute the correlation coefficient. So starting from A, the coefficient of determination is 0.92. Okay, so here r squared is a symbol for coefficient determination, and multiply that by 100 gives us the percentage here. So what you can determine what this means is that this could mean 92% of the variability in the output here can be attributed to the average number of emergency room visits. So it's read that way. 92% of the output can be attributed to the variability in the input. How much of it? In this case, it's 92% of the output is affected by variability in the input. Okay. Now they ask for the correlation coefficient. The symbol for correlation coefficient is R. Here, this is an important statement. Students get this wrong quite a bit. The correlation coefficient R is the square root of the coefficient of determination. R squared. So to find the correlation coefficient, we simply take the square root of it. The square root of R squared to get R. Therefore, the correlation coefficient is 0.96. And this one here, we have the tables here. See if there's one with it. Yes, there is one. All right. Make a scatter diagram for the data. Okay. So per capita GDP and per capita defense. So if we did X and Y, there's the dollars and how much they spend. There's the dollars they earn, they bring in, and then how much they spend on defense. Okay. So the minimum that's spent is 32. So this tells us how we want to scale this thing and set it up. And the minimum GDP is 51. So the minimum and maximum expenditures are 317 here. And the maximum being spent is 51, 1408. Oh, let's see here. The maximum being spent is 5178 here. Hmm. So the maximum being spent is $1,019.87 right there. So then you go ahead and you plot your data between 20,000 and 55,000 and see how it falls. So you have a kind of a slight linear relationship here. So it appears we have a strong positive relationship here. Correlation here, as I said, correlation, but just because they appear together doesn't mean one causes the other. Okay? Also, one could actually, but there again, one could cause the other. The higher the GDP, the more it can spend. The more our money is bringing in, the more they can spend on defense. That's another one like it. Another one like it. A unitless measure that describes the strength of a linear relationship between the two variables is called the correlation coefficient. The value of R, the correlation coefficient that represents a strong negative correlation, is -1. The value of R that corresponds to no correlation is 0. If one quantity increases and the other one increases, they're said to have a positive correlation. The line that the sum of the squares of the vertical distances between the data points in the scatter diagram, and the line is a minimum, called the line of best fit or trend line. Line of best fit, because it's the line that actually does the best job of describing the behavior of the data. How do you interpret coefficient of determination? R squared equal to 0.04 is that 4% of the variation in the dependent variable, the output, can be explained by variation in the independent variable, the input. That's how it's stated there.